Right, question 2. Let's see. F of x is 2x plus log 2. G of x is e to the 2x. That's quite small. I need to make that bigger. E to the 2x, right. Okay, let's write this down then. 2. We've got f of x is 2x add log 2, and g of x is e to the 2x. And we just need to do g of f of x. And we have to be aware of laws of indices, and the fact that, I mean, I'll write the laws down as we come to use them, okay, just to remind you. Okay, so part A. Oh, and x is all real numbers for both of these, right? Okay. Right. So I need to do g of f of x, which means I need to do e to the 2 lots of, not x, but f of x. So I need to do e to the 2 lots of f of x, which is e to the 2 lots of, and this is really important, right? It's two lots of the whole of f of x. So I should put a bracket and write 2x add log 2. And now this is an index laws question, where we also have to be aware of some log laws. Okay, so we'll get to those as we come to use them. So first of all, let's expand that bracket. So e to the 2 lots of 2x is 4x, and 2 lots of log 2 is 2 log 2. Now, you could do this in any order, really. Let's deal with this log first. Okay, so when you've got a number on the outside of a log, it can come into the log as the power. Okay, so we're going to use the fact that, well, I'm going to write it. So 2 log 2 is the same as log of 2 squared, which is obviously log 4. So the law that we were using there was n log x is equal to log of x to the n. This is for any base. Okay, so in particular base e, which is what ln is. So this can be replaced with log 4. So let's do that. So this is e to the 4x add log 4. And now there's something quite important about indices when you're simplifying indices. You tend to, well, let me write down what I'm trying to say. So you imagine I've got something really simple. You know, when you first learn about index laws, you learn things like this, right? A squared times a cubed, you have to do a to the 2 add 3, and you get a to the 5, right? So this is kind of wanting us to go backwards, okay? When you have a sum of powers, it's a product. It's a product with the same base and the 2 separate powers. So what this turns out to be is e to the 4x multiplied by e to the log 4. That's the point. The base is the same. I'm multiplying, so I would add the indices. Okay, so that's an index. That's an index law that, you know, year 8 students would learn, that we're using in reverse. Okay, so e to the 4x is what it is, and if you look closely, like, that is part of the answer. So we have to deal with e to the log, well, e to the natural log of 4. Now this here, this is now we have to use a log law. So let me just put that there. I'll move it in a second once we finish the question. The general log law, so let me use blue again. If I have log to the base a of a to the x, the log to the base a kind of, well, it kills that base and it recovers x. So this is like the fundamental definition of a log. This is really, really fundamental, and we can also write it with the functions composed the other way, because they are inverse to each other. So this is a to the log to the base a of x is also x. So these functions cancel each other out. Now you could try this out on a calculator. So if on a calculator you do 5 to the power of log base 5 of 17, you should get 17. Okay. Now this is what we're going to be using, because basically instead of a, it's e. Right. This is like saying e to the log base e of x, but log base e, we have a special way of writing that. It's an ln, isn't it? So that's e to the natural log of x, but of course these things cancel each other out, just gives you x. In this situation we're using 4, so let me write it again. Maybe I should have written it like this to start with, but never mind. No harm done. Is just 4, and that's the point. So let's kind of put that back into here. Okay, back into here. Okay, so basically what I'm going to do is, well, I'm going to try, see if this works. This is e to the 4x times, well, e to the log 4, with this ln is log base e. So these cancel out and you're left with just 4. So this gives you your answer of 4e to the 4x, because you bring that 4 to the front. Okay, and that's the answer. That's what it wants. So I'm just going to put that to one side. Remember, you can pause the video and you can ask questions in the comments. Right, part B, sketch the curve. Oh, okay, let's have a look. So I have to sketch 4e to the 4x. All right. Well, we can. I don't know how much detail to go into with my explanation, but that's a positive exponential. Let me make sure, from your perspective. So it means it goes up. Is that the right way for you? Anyway, I'll draw it and then so it's a positive exponential first of all. So it's a positive exponential graph, right? Which means the general shape of it is like that. That's what I was trying to do, like that. So it starts off very small, and you know, gets closer and closer and closer to the x-axis, but never crosses it, and then starts to shoot off, right? So it looks like this. A negative exponential literally just looks like that, with a mirror image flipped in the y-axis. So the general sketch is literally just that. Like, it is literally just this. You know, I'm basically done, except I need to work out this coordinate here. So the question is a simple one. What is y? So if y is 4e to the 4x, what is y when x is 0? Well, when x is 0, 4 times 0 is 0, e to the 0 is 1, 4 times 1 is 4. So it must cross here at well, 0, 4, or just 4 if I put that there. And then the x-axis being an asymptote is still the case. As x gets very, 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 very large but negative, it's going to be it's going to keep getting closer and closer and closer to 0. Y will keep getting closer and closer and closer to 0. So I really think that basically that's the answer. I'd be interested to see what the mark scheme says. So I shall just quickly. No, I'm not even going to look. I'll look after, because it's probably fine. It's only worth 1 mark. There you go. Right. And then C, the range of GF. All right. Well, the range is all the possible values that you can reach. So it's all the possible outputs. So if you look, I'll bring this back. If you wanted y to be negative, you can't do it, right? It never goes below the x-axis. If you want y to actually equal 0, so I mean, this is, generally speaking, one way. I mean, clearly, if the function is more complicated, you have to think a bit harder and break it up into cases. But generally speaking, I'm asking, can y be negative? Can y be 0? Can y be positive? So y can't be negative, and y can't be 0. We can get really close to 0, but we can never actually be 0. And then, can y be positive? Well, yeah, y can clearly be positive. Y can be any number bigger than 0. Y could be 1,000,000. Y could be 1,000,000,000,000. Y can be any number strictly greater than 0. So when we're talking about a range, we're asking about y. So I think you can literally write range of g of f of gf. I think sometimes that's maybe shortened to ran. I could be wrong. I'd have to check that, but you can definitely write. You could definitely just write this, and this is just all the possible y's. So this is a set. How could we write it? It's all the y's greater than 0. So it's y greater than 0. I'm pretty sure you know something. I'm just going to write it like this. Right? It's just that. Let's just leave it like that. I'm pretty sure that's the simplest way of doing it. It's just literally, as I say, it's all the possible outputs. Y, it's about y. So it's y is anything greater than 0. Okay. Right, that's the end of that one. Again, any questions or queries, please feel free to put a comment.